Bonsoir, mesdames et messieurs. Good evening, ladies and gentlemen. Bienvenue au IETF. Welcome to the IETF. We have an announcement to make. Il nous faut annoncer quelque chose. We're having a bit of a technical problem up front with the projectors. These lovely people are working on it. But we want to let you know that the download all of the presentations from the website now. This is a stress test for the network because we may have to go forward with the rest of the program with those in your laptops as opposed to on these nice big screens. So if you would like to find your way to the agenda page now and start downloading, the next step will be Brian Trammell, who will introduce our speakers and provide backing interpretive dance. I've been joking about that, but there's an actual separate stage for it. Normally we would let this debugging go on a little bit longer, but we have quite a tough schedule tonight, and a lot of people would be upset if we ran late. So we're going to try it this way. Please do download them, and please do give your attention to the speakers, even if there aren't any pretty lights. Many thanks. Brian.
Are the slides up on this machine? Okay. So I have the slides here on the monitor in front of me. So if everyone could please come to the front. Hi, I'm Brian Trammell, IAB, the MC for the technical portion of tonight's. Ooh, or you can hang out on Meet Echo, which will also be a stress test for Meet Echo. Also a stress test. So as a beginning note, you'll notice on the agendas that we're trying out something new this time. We're more explicitly splitting the tech and admin plenaries. You know, way back in the past, these were on separate evenings, and then they sort of came together, and then they sort of came even farther together into a single session. We are splitting these out explicitly to make sure that we have enough time for the tech plenary as well as enough time for the admin plenary. This part of the session is 1 hour long, which is why we were going ahead and getting started, even though we don't have video yet. We're going to be holding pretty strictly to time. There will be time for questions and discussion at the end. You know, clarifying questions only, but please no clarifying questions. With that, privacy, question mark. What's the delay on? Okay. All right, yes. Next slide, please. As some of you may be aware, the IAB and the IETF, at least we hope, many in the IETF, is deeply interested in confidentiality on the internet. This is a conversation that we've had ongoing for a while. We're interested in this in large part for reasons of privacy. We spend a lot of time in the working groups these days. Woo! That is the most applause I thought I would ever get for privacy with a question mark in an IETF meeting post Vancouver. I'll go ahead and it gets better. We've been talking a lot about in the working groups and in the hallways and you know, around the working groups and in the press and sort of everywhere. It's been a while since we've addressed it in plenary, so we'd like to change that. Tonight we have a program where we'd like to talk about current issues and eternal issues in internet privacy with Arvin Narayanan. I worked so hard to get your name right. And Steve Bellovin. Arvin Narayanan is an associate professor of computer science at Princeton. He leads the Princeton Web Transparency and Accountability Project. He's also the recipient of the Presidential Early Career Award for Scientists and Engineers. There's a award ceremony for this that he's missing to be with us tonight, so we're very, very honored to have him here. He'll be talking about some of the implications of current trends on communications privacy in large, current trends on communications privacy in the internet sort of in the large. So he has sort of a contextual look at this. Steve Belvin needs no introduction in this room, but I'm going to try to do so anyway. He is a former member of the IAB, former security area director. He was instrumental in the creation of Usenet. Some of you may have heard of that. He's currently a professor of computer science at Columbia and an affiliate at Columbia Law. He will be showing us tonight that in internet privacy, everything old is new again. So thank you both. Arvind, come on up.
All right. Hi, folks. Can you hear me? I guess not. Okay, I'll hold it at arm's length. All right. Thank you, Brian. Thank you, everyone. So I'd like to share with you what I've learned from a decade of doing privacy measurement. Privacy measurement is kind of a boring sounding term, but what it really means is trying to find privacy vulnerabilities, ideally on a large scale. I'm talking millions of endpoints in an automated or mostly automated way. And before I do that, I'll start with a couple of caveats. One is I want to be really upfront that most of my work has been in the web space, and my prior engagement with standards agencies has been with the W3C. And that's what a lot of this is going to be informed by. But nonetheless, what I'm going to try really hard to do is extract some principles that are much more broadly applicable, and that's what I'd like to share with you today. And another thing that's going to be a common theme of the presentation is that I'm going to be talking about issues beyond encryption. I'm going to assume that we're in a world with pervasive encryption. And in fact, some of the things that I'll touch upon are perhaps some downsides of encryption for privacy and how we can try to mitigate them. So that already sounds surprising to some of you, so I hope this will be an interesting discussion. I should also say that, as you heard from the intro, I'm an academic, so my job is to think, idealistic blue sky thoughts. There are going to be points where you're going to feel, oh, this will never work in the real world, and you're welcome to come say that in Q&A. That's totally fair game, and I appreciate that. Okay, so with those caveats, here are 3 things that I want to share with you. The first thing is an issue that very often comes up when we're talking about privacy beyond encryption, especially when we're talking about more subtle privacy threats such as device fingerprinting. An argument that often comes up is, oh, forget about fingerprinting. That ship has sailed. The horse has left the barn. It's too late for fingerprinting defenses. There are too many fingerprinting vectors. It's too easy to do tracking. So we should just forget about that and accept that we're going to be in a world where it's really easy to track and profile people. And that is a point of view that I actually used to subscribe to. And what I want to tell you about is why I changed my mind at what I'm looking at. So that's the first thing I want to tell you about. And specifically, this has come up a lot in the web context. So let me start with that. Now,
printing. And ironically, you can see on the list, privacy features like do not track also contribute to fingerprinting. Because do you have do not track enabled or you not have it enabled? So that's a small amount of entropy, et cetera. So one thing you might conclude from this is, the horse has left the barn. Fingerprinting is devastatingly effective. we shouldn't even try to minimize the fingerprintability of new features that we put into the standard. Now, the W3C, to their credit, there were a lot of people who still tried to minimize the fingerprintability of new features. And I don't want to present this as a criticism of other people. This was absolutely me up until about a year ago. So this is what I believed, and here's why I changed my mind. So those studies that I presented, they were really, excellent studies, but there was something wrong with the way that a lot of people interpreted them. One weird thing about those studies is that the users who participated were self-selected. So does that mean that the results could be non-representative in some way? What could be different about self-selected users? One possibility is that all the users who would self-select into a study like that are actually really tech-savvy people, the kind of people who are likely to make a lot of modifications in their browsers that would make them more unique and more fingerprintable. So that was one interesting kind of bias that some researchers suspected could be in those studies, including some of the researchers at INRIA who were responsible for one of those studies. And then what they did was they partnered with a major French website and fingerprinted all of the users of that website without really telling them. So by doing the slightly ethically questionable thing, they did a statistically much more rigorous thing, and they published that study, which found, in fact, contrary to some of the previous findings, only a third of the users were unique. And as more and more activity shifts to mobile, less than a fifth of mobile users were unique because those devices are less customizable. And further, as Flash and Java and other old plugins are getting phased out, that number is actually going down. And if you look at, for me, when I looked at the findings of this study, the conclusion was very different. Even little things that browsers can do in order to minimize the fingerprintability of features are going to have a big impact. And so I came away with this with a very different point of view than a lot of people had had before the study, which is let's not even bother, let's not cripple features for the sake of privacy. But instead, after the study, what I concluded was quite the opposite. So I think this is a much more general principle. In a lot of contexts, we hear the ship has sailed, the horse has left the barn kind of argument. And if you were at Pete Snyder's talk at PARG earlier today, you heard a lot of similar points from him as well. You know, the same kind of thing that I'm saying here. So that's the first kind of insight that I want to give you. The ship has not sailed. And one of the reasons that people will say that the ship has sailed is that if you don't have a perfect defense, even if you try to mitigate fingerprintability, oh, here's a clever way that somebody can get around that. Why have an imperfect defense at all? Is it not better to not give people a false sense of security? So that is a point on which I will disagree. I think that imperfect defenses are still very useful. And one reason I believe that is because technology doesn't have to bear the full burden of privacy protection. What do I mean by this? Here's an interesting example. Safari has third-party cookie blocking, as you might know, and it's not a perfect defense. It can be circumvented. In fact, Google decided to do exactly that. Google decided to circumvent it, and once they did, something interesting happened. In the US, the Federal Trade Commission got involved. They said, hey, you can't do that. You can't circumvent a privacy measure. That's actually a violation of the law, and they went after Google, and they fined Google. So that's an interesting phenomenon where the technology itself was not bulletproof, but it turns out that circumventing even a weak privacy protection measure can actually get companies into trouble with the law. It can also be a reputational harm. So when we're talking about the privacy adversaries here, we're talking about the Facebooks and Googles of the world. We're not talking about somebody from a poorly regulated jurisdiction somewhere out there in the world. And therefore, technology doesn't have to bear the full burden. Imperfect defenses can still be useful. Even if all that it does is raise the cost of some of these fingerprinting and privacy invasive features, and it takes a couple more years for those kind of tracking technologies to become very widespread, that is still useful because it gives a couple of years for new defenses to be developed, whether they may be technical or legal or something like that. So that was point number one. Point number two that I want to talk about is we're in a world where what privacy means to people changes very quickly. Whether or not something is a privacy breach changes very quickly. So both privacy attitudes and privacy infringing technologies change pretty quickly. How can standards cope in this world, given that standards are intended to be pretty long-lasting documents? And so how do you resolve the tension between these two? So one good example of this is one of my favorite examples of how privacy attitudes evolve quickly, is that if you thought about privacy 10 years ago, most users would have been concerned with what are the individual harms that can accrue to me out of all of this data collection, out of all of the databases owned by companies that have my personal information. Is it identity theft? Is it data breaches? Is it perhaps targeted price discrimination? What should I be worried about? Those were the kinds of privacy questions that people were asking. People are still worried about those privacy issues, but now people are increasingly worried about a very different kind of privacy issue, which is what are the threats to society overall and perhaps to democracy from all of these massive collections of personal information, especially after recent stories like Cambridge Analytica. People are very concerned about what is the potential of hyper-personalized targeting to affect, the overall society that we live in. So I want to say that there has been a shift from these very individualized concerns about privacy to more collective societal concerns about privacy. Among privacy scholars and privacy advocates, that shift has been pretty stark, and even among the general public, I think there has been a substantial shift. And so what this means is that a certain type of data collection that might have seemed pretty innocuous 10 years ago begins to look very different today. So that was one example. I have a couple of other examples that I'll skip. But the result of this is that it's very hard in a standards document to write down a fixed privacy definition and then say that I've analyzed this protocol with respect to this privacy definition, and I'm confident that this is going to be a privacy respecting protocol now and for all time to come. Right. And so going back to that example of individual versus collective harms, let me show you very quickly the paper by Cambridge researchers. This was in 2013. This was the paper that realized that you could take people's Facebook likes, which is a very innocuous sounding type of information, and use that to predict their so-called big 5 personality traits. And those are things like emotional stability, agreeableness, extroversion, and so on, the stuff that you see in green over there, if you can even read that text. Sorry about that, the font size is a little small. And this is exactly the research that was allegedly weaponized by Cambridge Analytica for psychographic targeting. So this was not necessarily anticipated a few years ago. There are many other examples of this, of improvements in machine learning, turning innocuous data into something that can be used for something much more problematic. This was a headline from a few years ago. Statisticians at Target had figured out how to use a person's shopping records to figure out whether they were pregnant or not. And so one concrete threat along these lines is well stated by Paul Ohm, who's a legal scholar, who calls this the database of ruin. He asks us to imagine the consequences of a single massive database containing secrets about every individual formed by linking different companies' data stores. And I think one of the technologies that is enabling something like this today is cross-device tracking. Techniques that enable the linking of our activities between different devices, even if we're not identifying ourselves using explicit identifiers that allow such linkage, just using statistical patterns to link these different devices together. And I think these types of concerns should perhaps be at the forefront of some of our privacy efforts, including in standards efforts, but these are not things that we really recognized as privacy concerns maybe 10 years ago as much as we do today. So that's kind of what I mean by the landscape of privacy is shifting pretty quickly. And this is a challenge for a standards document and a standards process, which needs to be really long-lived. So we thought about this in a paper recently where we looked at specifically the battery status API in the web context. And this was an API that turned out to have much more serious fingerprintability privacy consequences than was realized, and therefore was taken out of a number of browsers after it had shipped and after people had started using it. That was kind of unprecedented. So we looked at how did this go wrong and how can we be more aware of these potential misuses during the standards process. And so here's the paper citation at the bottom. And what we proposed in this paper, at a high level, what we called for is a much tighter loop between standards agencies as well as researchers and developers. And by developers, I mean both implementers and also developers in a much more general sense, people who are using the APIs that are implemented by the browser vendors, for example. And as part of this, we think that it would be really useful to incentivize academics to do two things. One is to get involved in the standards process and do privacy reviews of standards. And the other one, this is perhaps still quite missing, which is once an API is out in the wild and once people are using it, to do regular privacy audits of how it's being used and abused. I've talked about this a few times, and one question that I get is, sure, this sounds good in theory, but it's hard to convince researchers to do this. How do we do that? Now, one good thing I'll say about this actually sounds like a horrible thing, but I'll claim it's a good thing, is that it's fairly easy to influence academic researchers. Influence them not in the sense of what they'll say, but influence them in the sense of what they want to work on. By funding certain work, or by making it more prestigious, by creating awards, for example, for certain types of work, such as privacy reviews of standards. I think it's there's a fairly straightforward path to incentivizing much more academic work as part of the standards process, which I think will be a good thing. Another thing that I think would be useful is, as part of the standards process, to be explicit about assumptions. Because privacy changes so quickly, because we can't anticipate what new privacy infringing technologies will be out there in 5 years, it helps to be explicit about assumptions as part of the standards process. That is, to be able to explicitly say, we have created the standard assuming that this API will not be highly susceptible to fingerprintability, but if it turns out that that's the case, if it turns out that this is being exploited in the wild, here are some things that implementers could do to mitigate that risk. So that's the second point. Okay. And the third and final point that I want to talk about is that this idea of measurement, which is finding these privacy violations on a large scale, I'm claiming that it's been really useful for privacy, but unfortunately, it's going away, and I want to talk about whether there is a way to preserve it. I don't want to make this sound like a sky is falling kind of claim, but in my little corner of the research world, the sky has already fallen, and a lot of us have moved on to other research areas. So let me tell you why that is and why that should worry us from a privacy perspective, and to see whether there's a way to preserve it. So I'm claiming that, at least in the web context, measurement has played a very key role in keeping the worst of the privacy abuses in check. Many teams around the world have been working on web privacy measurement. I'll tell you a tiny bit about my own team's work. Something that we built is a tool called OpenWPM. This is the GitHub page if you want to check it out. As you can see, it's an actively developed open source project. It was developed at Princeton, and now the main developer, Steve Engelhardt, has moved to Mozilla. It's maintained by Mozilla now. So what it is, I don't mean for any of the details on this page to be important. It's just the URL if you want to look at it, or the name OpenWPM. What it is an instrumented version of Firefox. It's basically a bot that visits the web's top 1 million websites every month and looks at what kind of privacy violating techniques are out there. It even does things like put in fake PII into various forums and tries to see where they go. And it saves all that data. We have 0.5 terabyte of data per month, and then we run various scripts on that data to try to find privacy violations and publicize them and get people to change their practices. We've written a number of papers based on this data. This is one example. It's called Online Tracking, a 1 million site measurement and analysis. And as you can see, one of the key things here is to be able to do this on a large scale in a mostly automated way. It's had a number of positive impacts on privacy. One of them is enhancing block lists. For example, if you use AdBlock Plus or uBlock Origin, those tools use filter lists, and the developers of those filter lists often look to research like ours to try to figure out what are some of the new privacy violating endpoints in the URLs in order to add them to their block lists. Various other things. For example, in some cases, there's been enforcement action by data protection authorities, by the Federal Trade Agency, and things like that. So I'm claiming that this kind of research that's been done by many groups around the world is one of the main reasons why web privacy has been, kind of at an equilibrium, hasn't been even worse than it already is. Now, the important point, though, is that 5 years ago, a lot of us thought that we were going to do this very same kind of work for IoT, because we were hearing that a lot of the IoT devices in our homes have occasionally have surreptitious data collection that consumers did not know about. And so we wanted to do this kind of work, but we very quickly realized that we can't actually do this work because of one very simple reason, which is that most devices are end-to-end encrypted, which, to be very clear, is a great thing. It's great for privacy. They should be end-to-end encrypted. Unfortunately, the downside of that is that the two ends, of course, of end-to-end encryption are the device and the server. It doesn't involve the user. It doesn't involve a researcher. A researcher can't minimize these devices. A researcher can't figure out what data is being collected and where it's being sent. And we think this is kind of a crisis for this kind of research. It makes meaningful privacy measurement basically infeasible. The public is very interested in these questions. For example, there was this article called "The House That Spied on Me" that just looked at what are the endpoints of communication of various IoT devices, including sex toys. Why is that contacting 13 different servers? You know, people want to know what data is going out there. And this is important not just from a privacy advocate point of view. If you're a company and you're a reputable company and you want to be able to show your users that your data collection is completely according to your specified privacy policies, there's no good way to do that today because researchers can't examine the plain text of these communications. And I think this is a serious issue. For example, if we wanted to know if the smart light bulbs in our homes are transmitting conversations because they actually have microphones, we really don't have a good way to check that today. And this is not a totally paranoid scenario. Something somewhat similar has happened. For example, this interesting thing happened a few months ago where Google sent an email to all of the owners of Nest thermostats and said, hey, your Nest thermostat is also a Google voice assistant now. And people are like, what? How is that possible? It doesn't have a microphone. And Google said, no, it does have a microphone. And people said, what? We didn't know it had a microphone. And Google said, yeah, it does. Check the privacy policy. And people said, what privacy policy? Nobody reads the privacy policy. Also, when they read the privacy policy, it was actually not in there. And then Google said, oh, we meant to disclose that in the privacy policy. Sorry, that was an oversight. So, of course, in this case, I'm willing to believe that it was an oversight on the part of Google. But if there was a malicious, vendor who put microphones in devices that are in millions of people's homes, we literally don't have a good way to know about it. This measurement research has been in the past one way to know about it, but it doesn't work for IoT. So with that, I'll just end by saying that what I'd like to call for is some kind of debug mode for IoT devices. I think this is a critical need. The idea being that when you enable this kind of debug mode, the user, or more likely a researcher, the details and user experience will depend on the device, but some way to be able to intercept the plain text in order to be able to audit what's going on out there. There's a Stanford project related to this called TLS, what is it called? TLS Replay something. So what I'm proposing is slightly different. I'm happy to hash out the details later. This is not necessarily the time for that, but I think some way of being able to examine the communications of IoT devices is critical, and I think there's a role for standardization here. With that, I'll just put the summary back up, and thank you for your time.
Thanks. So, okay. Okay. That's. So I'm going to talk about some modern issues in privacy today, and privacy is not a new issue. When I started doing the research that led to this talk, and by the way, these slides are already on my webpage, and link to references, a technical/legal document is also on my webpage. A lot of this stuff goes back to the 1960s. The New York City Bar Association started studying computers and privacy in 1962. Alan Weston prepared basically a report of that committee in 67, been very influential. The US Congress held hearings on this. Legal academics were writing papers on this, all in the 1960s. And it actually goes back, the right to privacy is mentioned in Jewish literature about 1800 years ago. So it's not a new issue. And the privacy that we use today, the privacy paradigm called notice and consent, goes back to Weston's 1967 book, which is the report of this Bar Association, the City of New York Committee, that individuals can determine for themselves what they want to share and what they're willing to reveal. And this statement from 1967 has been the basis for virtually all privacy regulation since then. And you look at the timeline. He published this book in 67. 6 years later, a US government committee came up with what became known as the Fair Information Practice Principles of consent, of security, of openness, of use specification, and so on. And in 1974, a year later, the US government actually enacted this into law, but only as applied to the US government. Didn't apply to private corporations, not the American way. A few years later, the OECD suggested more or less the same thing, but applying to the private sector. In 94, the EU enacted the Data Privacy Directive. 7 years ago, the GDPR was enacted, went into effect a couple of years ago. But from 10,000 meters, all of these are substantially the same. Yeah, tremendous difference in details. But fundamentally, if you consent, the data that you have, the data about you, can and will be collected. And notice and consent. And so notice and consent is sites tell you what they're going to collect and what they're going to do with it. And by using the website, by using the device, you are deemed to have consented to this policy. And some of the risks were known back in the 1960s. Academics, law professors wrote, people are just going to go along with requests because they want the service. 1960s. We didn't have Google. We didn't have Facebook. They realized people are going to go along to get the benefits. They realized, they told the US Congress, people are going to share passwords. Maybe we need multi-factor authentication. 1967, folks. How many sites do you log into with just a password today? They worried about hackers. They even cited MIT, the MIT students breaking into systems for fun. Insider threats, wiretapping, the need for encryption, the importance of metadata and the inferences you can draw from metadata. In, again, 1967, 1969, the danger of large searchable, aggregatable databases. All of this was known and largely forgotten. So we haven't solved the technical problems of from more than 50 years ago. We still have notice and consent, though. Does it work? No, not even close to working. There's a tremendous amount of data that's collected, and we don't know who is collecting it. We have privacy policies, we have location data, and of course, there are the governments of the world. There's a tremendous amount of overcollection. Apart from all the folks to whom you give consent, there are the data brokers, outside parties, whose business is to collect data about people and sell it. They collect it, they buy it, and they sell it. Sometimes from public records, sometimes from private transactions that you know nothing about. Last year, I sold a car. I found out that my odometer readings had been sold by my mechanic. Well, yeah. Did I consent to it? No. That was a private deal between the mechanic and some data collection company. The ads that you see on the web, they're generally not coming from the website you're visiting. They're coming from ad brokers, often multiple levels of ad brokers who do HTTP redirects. Each one is a separate website and collect and set cookies. So lots of folks are gathering data about you, and you don't even know who they are. And the third-party like buttons, like Facebook and Twitter, and the third-party authentication, Facebook and Google, tells these collection sites what sites on the web you're visiting. These analytic platforms are used to build up profiles on people, and there are companies, calling out Rubicon simply because they're cited in a New York Times article. They take what they know about you from the tracking cookies, they combine that with information from third-party data aggregators, and estimate based your age, your gender, your income, and use that to say, how valuable a customer are you, and therefore what ad is appropriate to show you. And you don't see any of this. But we have privacy policies. No, out of curiosity, who in this room reads every privacy policy they encounter? I'm impressed. I am seriously impressed.
Security ADs, hands down.
There are, my hand was not raised. There are, Lori Craner and her colleagues at Carnegie Mellon estimated that the opportunity cost for reading all the privacy policies you encounter would be about $3,500 US per year. And they're deliberately vague and deliberately expansive because, at least in the US, regulators will come down on you not for what they collect, not what you collect, but from when you break your promise. That's an unfair and deceptive trade practice according to U.S. law. So if you say you might do everything, then you don't lie when you do everything. We may collect personal information and other information about you. Remember the data brokers, remember the analytic platforms, from business partners, contractors, and other third parties. In other words, the world. Quote a advisory committee report to President Obama about 5 years ago. Only in some fantasy world do users actually read these notices and understand their implications before clicking to indicate their consent. By and large, that's true. And remember, because of all these third and fourth and fifth and sixth parties on the web, you don't even know what websites you're consenting to. You go to a news site, a sports site, what have you, and you're careful, you read it, and you look at the fine print and says, by the way, read our advertising partners' privacy policies too. Who are they? Good luck finding out. Location data is a huge issue for mobile devices. Lots of apps are collecting and analyzing this kind of data. And even if the app is not doing the collection and transmission, IP geolocation, a very mature technology, reveals a lot. Is it perfect? No. Is it very, very good? Yes. And this stuff doesn't have to be perfect. If data exists, it's available to governments. Sometimes in some governments, you've got a complex, restricted, and somewhat painful process to gain access to your data. I said, the US government had this 45-year-old privacy law. You can, under certain circumstances, gain access to certain information held about you. Other governments don't really care about the niceties of privacy policies and access. It is your data. We want it. We have it. Go away. And of course, that's even ignoring what 193 nations in the UN. I think about 192 of them have espionage agencies. They collect data via technical means and other means. And this you don't get to look at all. The privacy laws that we have are largely based on what's called PII, personally identifiable information. Your name, your email address, a government ID number of some sort. The definition varies. The EU considers IP addresses PII. Much of the United States government does not. I'm someplace I think they're both right, depending on the circumstances. But it turns out you don't need PII to invade somebody's privacy. Amazon doesn't need your name and address to recommend products. Oh, they might like it. Oh, you live in a well-to-do neighborhood, we're going to recommend more expensive products. You have an ethnic surname, family name, let me go recommend products that appeals to that ethnic group. So they can help, but they don't really need that. People who bought this also bought that. Netflix doesn't need to know who you are to recommend movies. TiVo doesn't need to know who you are to recommend TV shows. It's a great essay out there you can find, search for it, called My TiVo Thinks I'm Gay. Somebody overreacted when he started getting recommendations from TiVo for gay-themed movies. So he started deciding to overcorrect by watching manly He-Man movies, war movies, and so on. At that point, it started showing him Nazi propaganda movies. PII is actually just a database key. But the database records exist on their own, can be used for lots of things, even without the key to look it up and to merge it. If you're worried about PII, some people try to anonymize the data. We'll strip off the identifying information. It doesn't work. First of all, for most kinds of anonymization, the real world has shown it's easy to re-identify. Or you've done some of that, as I recall, haven't you? And if you do too good a job of anonymization, you may actually destroy the utility of the data for certain very important things. For example, some medical dosage calculations done based on machine learning on a large database of patient information, very successful at calculating the proper dose of warfarin, which has been a very tricky problem. But Some academics showed that if you anonymize the data well enough to really hide the patient's identity, the calculations wouldn't work. You've hidden too much of the subtle details about the patient's medical condition. So take your choice: identification, utility, even for things that we all agree are useful, like medical research to benefit everybody. PII, focusing on PII also misses the importance today of machine learning and the inferences that it can make. You can tell someone's sexual orientation from the kinds of things they do. We'll ignore that my TiVo thinks I'm gay, but you can infer this. Is this good? Is it bad? It's private information to a lot of people, whether or not it should be. It's much, much harder to control because it's not based on data directly collected. You can say you cannot collect information, say, from my doctor on my sexual orientation. But maybe there are proxy variables that tend to indicate it. The foods that I buy might indicate my ethnicity. Proxy variables are a very powerful thing. There was a study done by the U.S. Federal Trade Commission about 10 years ago. They discovered that auto insurance companies were using credit scores to set rates. What does your ability or willingness to pay a debt have to do with whether or not you're going to get into an automobile accident? And the FTC staff came to 3 conclusions. 1, it was a valid predictor. Why? Well, machine learning doesn't tell us why. It just says there's a correlation. This is a good predictor, and insurance is about prediction and statistics, not about causation. 2, there was also a correlation with ethnicity. The higher rates were going to certain ethnic groups based on credit scores. Well, that's bad social policy. So the FTC staff said, we're going to solve this. We're going to try to build a model that's just as predictive but not discriminatory. And guess what? They couldn't do it. There was something deep in the data that said, yes, there is this true correlation that's going to discriminate if we don't do something in a regulatory fashion against certain ethnic groups in setting rates. It's very hard to find and eliminate all of this. And it's got nothing to do with PII. So, to me, notice and consent is dead. No one knows who collects the data. No one knows what they'll do with it. No one knows where it's stored. And some of the most sensitive stuff, like location, is dual use. It's used for your benefit, How do I get from point A to point B in a map program? And it's part of what's called your data shadow. Even the U.S. Supreme Court has noted how sensitive location data can be in the aggregate. So if we don't have notice and consent, what should we do? What should we replace it with? One answer is use control. It's controversial, but give up on data collection restriction. It doesn't work. Better in the EU, but still doesn't work that well. Instead, let people specify how their data can be used, not what can be collected, but what it can be used for. Targeted advertising, statistical analysis, medical research, what have you. It sounds like a great idea. It's not that easy. How do you define your use categories? How do you give people a really usable interface to specify, here's a kind of data we're collecting, and here's a kind of use that you may or may not want to permit for this kind of data? Usability of privacy settings is a fiendishly difficult problem. Very few, if anyone, has gotten that right. You've got to give consent across long time intervals. I have been posting stuff on the net for about 40 years now. As Brian mentioned, I was one of the people who created NetNews, which went live in January of 1980. I was one of the founders, so I was out there from the very beginning. Do I have the same preferences today as I had 40 years ago? Well, I was lucky. My first boss at Bell Labs when I walked into his office a few years after that, said, "I've seen your flames on Net News, Steve." Yeah, yeah. Okay. Upper management reads these things. Yeah, okay. Data that exists can be abused by hackers, scofflaws, governments, or simply through a change in the law. And it turns out that under US law, it may be impossible to mandate use restrictions for companies. They can adopt it, but you may not be able to mandate it under US law. So how do we implement this use control? You can start with a privacy-preserving credential scheme, tag all the data that you create with a privacy-preserving sub-identity and a data type. And you can publish tuples saying data type, anonymous identity, allowed uses, and all digitally signed with your anonymous credential, pseudonymous credential. And where do we put it? Well, gee, do we put it in the blockchain? Okay. No tomatoes, please. And if you change your mind about something, you just push out something. It's your newest statement that wins. Enforcement, well, as often pointed out, governments have a role. If you break a legally binding promise, if you break a law, governments can come down on you. Difficult, but might be doable, might be worth examining as a research project. What we really need is a new privacy paradigm. It's got to scale to very many data collectors, known and unknown in the future. It has to scale across time. It's got to be comprehensible by individuals. It's got to account for inferences. It's got to trade off the harms and benefits of different kinds of data use. And I have no idea what such a paradigm would look like. Of course, that's for me as an academic, that's great. If we knew the answer, it wouldn't be research. But this is the real challenge. How do we do this? So what should the IETF do? Obviously, encrypt as much as possible. The IETF has been moving in that direction for more than 20 years, and that's great. Avoid creating unnecessary third-party metadata. One place this really shows up in protocol definitions is stuff that's left to the implementation, because that becomes fingerprintable. How about, to pick one random example, if the HTTP headers could only be in a certain specified order, and even if they were null, you had to specify it and had just a semicolon or something. Design more privacy protocols. Do a privacy analysis of protocols similar to what is done for the security considerations today. Some years ago, there was the GeoPriv working group. Geolocation said, okay, this is dangerous stuff from a privacy perspective. Let's look at it first. Tagging might help, create some more metadata. So here are the references. Most of the quotes are from my comments on privacy, again, written for US legal context. I apologize, quoted assorted academics from 50 years ago. Thank you.
Thank you very much. With that, we open the floor to questions. I have Elliot.
Hi, this is Elliot. Steve, Arvind, thanks very much for your presentations. Two comments. First of all, related to Arvind's work, I'm very pleased to fund a colleague of yours, Serge Egelman at Berkeley, who's done a lot of work in this space, particularly around linkages on cell phones. And the idea that you have about TLS and privacy of IoT is something that I am deeply involved in. And one of the things that it raises is the question of privacy brokerage. We release this information, oftentimes we release information for a purpose. And the notion of contextual privacy is something that I think is relatively nascent, if I understand in terms of the research. And I'd be very interested to see us continue that discussion here at the IETF, or at least at the IRTF, as to what that means. And this goes to the tagging that you mentioned, Steve. So thanks for your research. And if people haven't looked at Serge's work too, he's done a lot of work, particularly around the Amazon Echo recently. That's very useful. Thanks.
Thank you. Barry.
Hi, this is Barry Lee. This is a very live mic. Hi, this is Barry Lee. But Steve, how does notice and consent and GDPR work with being tracked by Facebook and Twitter icons and the like.
That's another reason notice of consent doesn't work. You're being tracked by lots of people with whom you don't have a direct relationship, and how can you consent? Can I say I don't consent to seeing a Facebook like button on a web page I want to visit?
Do you have any idea how they have not been attacked by the GDPR people?
I'm not a lawyer. I will let the lawyers answer that one.
That's fair.
You have Aaron?
Aaron Falk, so there we go. So this is actually, I'm interested in responses from both of you that there's been a lot of interest in the IETF in privacy issues around the DNS. And so I'm wondering what you think of the risks, privacy risks around that, and whether DOT and DOE provide useful solutions.
Privacy, like any other security problem, has to be done in the context of a threat model. Who is trying to collect this data? What are they going to do with it? You know, with DNS over HTTPS over TLS, you know, you might get a central aggregation point, and do you trust them to be honest, secure against governments who come armed with legal process? And you don't necessarily have a business relationship. It's not clear to me that guarding against the NSA or GCHQ or the FSB or GRU or the Mossad or whomever is the best threat model versus the commercial threat model. That one might actually be best dealt with laws saying your ISP cannot collect or use this data in any way, rather than this technical mechanism, and avoids the central point of collection, which is a greater threat against certain threat models. What's the threat model?
Mallory.
Hi, Mallory Nodal, Article 19. So my question's for Arvind. I really liked your example of how a limited technical mitigation encouraged a strong policy that then filled that gap for user privacy. This was like about a third through your presentation. And I think that paralleling that example with your conclusion is also interesting. So I guess my question would be, and then I can explain a bit more if that's helpful, is, I mean, I think there is a role that measurement and research can still play, even if it's limited now because of the privacy enhanced protocols that we're using. How can we instead pivot, instead of trying to bargain, like in the stages of grief or in the bargaining stage, like how can we do both of these things when there's an actual inherent technical paradox between the two, and rather pivot into a more complicated relationship between policy incentives, policy sticks, and then, you know, so I wonder how academic researchers can help, for example, not human rights, but like impact assessments, or getting companies to take more responsibility for doing privacy audits, security audits. And it's a slower approach. It's not as fast as scanning 1 million websites every month. But I think that where we're at now, and the way that we've advanced privacy for end users, to get the higher hanging fruit, we actually have to have more complicated approaches.
That's great, thank you. The way in which I think measurement research has helped at a very high level is, in economic terms, closing the information asymmetry. And what I mean by that is when a product doesn't live up to its privacy claims, oftentimes the buyers, users, consumers of that product don't know and have no way of knowing. And this parallels in the United States one of the critical situations that we had with respect to used car sales 40 years ago. And the matter became so critical that buyers of used cars would not know if the car had a critical defect, whereas the seller would know and would not tell them. And it was exactly the same kind of problem that was faced. Economists call this an information asymmetry. And that particular information asymmetry was closed by lemon laws that mandated certain information disclosure, that guaranteed the right for buyers of cars to first take it to a mechanic to be inspected and so on. So broadly, to your question, as long as we have some way of closing this information asymmetry that exists between the sellers of products and services and the people who use them, I think we're in good shape. And one of the ways we've been doing that is with academic research that's been, scanning 1 million endpoints at once, but it doesn't have to be the only way. Another critical way to do that has been journalists who've been, individually examining these products in a lot of detail and holding companies' feet to the fire. So as long as we have some oversight mechanism, whether that comes from law, whether that comes from academia, whether that comes from journalism, or whether it simply comes from a more informed public that helps close this information asymmetry, then I think we'll be in better shape. Thank you.
Thank you very much. Okay, up here, up front.
Okay, so Peter Feil, Deutsche Telekom. So from my point of view, that was an excellent presentation, but it was very technology oriented. So we have, and also very North American oriented. So in Europe, especially in Germany, we have very severe laws regarding privacy. So you mentioned the GDPR, which is in effect since last year, basically. And I don't think that we can solve this issue from a technical point of view. It's a legal issue. So in Europe, I don't know if you read the news, but Facebook will probably have to pay some billions because they did not follow the rules of this law. And in Europe, any data I give to any company is owned by me and not by the company who gets this data. So this is something that has to be changed worldwide, so especially in the US. And again, I just wanted to point out that it's not a technical issue, it's a legal issue. Thank you.
I agree completely. The document that I wrote, to which my talk was derived from, was a submission to a U.S. government process on privacy. Because I agree completely that there's a very important legal role for legalities here in governments around the world. But I think that trying to base your privacy on notice and consent from a technical perspective is not going to work. And I want what my paper said is we need to find a different paradigm for regulators and legislators to mandate.
So thank you for your comment. I completely take your point that the role of regulation in the law is very critical here. Thank you for bringing up the GDPR. One thing I want to slightly push back on is that I wouldn't see it as a technical or legal issue. I don't think it's a dichotomy. In fact, a lot of the investigations that have come about under the GDPR and the fines that have resulted from that, those privacy issues only came to be known because of the kind of research that I described, whether it was done by academics, journalists, or some other third parties. So that's technical work in a sense. And for me, the real success stories involve the collaboration between technical teams and legal measures.
Thank you. We're going to go ahead and close the mic line, so we'll drain the queues. Please be brief.
Okay. Hi, Juan Carlos Zúñiga, Sigfox. Thank you very much for your talks to both Stephen and Arvind. I wanted to actually follow up on this discussion because, in fact, that's precisely what I wanted to say. In this world where we believe privacy is getting harder, the battle is lost, I very much appreciate the message of no, it's not lost, we can keep improving things. And also, just following up from the previous speaker that we are going all the way from the extremes of regulations towards the purely technical, and I think they both have to marry at some point in time. It's true, we don't have the answers to all the questions, and it's true that, for instance, I was recently in a regulatory discussion where they were just discussing, okay, in a world where the watch is checking your vital signs, and then it's sending it to your phone, and then that's sending it to an app, and that's sending it to a cloud provider, and who do you regulate? It's not anymore the world of one piece does one thing. So it's important. I agree with Arvind on the message that we can help the regulatory bodies understand that is the service provider probably the most accountable one that will make sure that the information flows down. And also on our side, as a technical writers, we do have indeed the role of writing the right standard, but also educating people as much as we can. Regulatory, it could be a section. Stephen, you mentioned the privacy considerations. I think that's a great way to communicate what the standard should do, what are the issues, what should be looked after, and then follow up and make sure that we do improve, because definitely the battle is not lost, and there's a lot of things we can keep doing.
Hi, Riyad Wabi. Arvind, you mentioned at the very end of your talk a more project out of Stanford, TLS RAR, rotate and release. I was one of the authors on that. So I think you're absolutely right that there are some technical measures like that. But just to provide a little background and kind of a counterpoint, while we were working on that, we actually spoke with some of the people in the TLS working group and said, hey, look, it might be the case that like a small change to TLS would actually make this easier. And we very rightly got pushback from the TLS working group who said, yeah, but we don't want to make this easier because, yeah, you might want to use it for watching your own devices, but anything that we make easier for you is going to also be easier for somebody who's spying on you. So while it's true that we want to look at our devices, it seems like technical measures at the level of, you know, the encryption standards, maybe not the right way to go. We may be in some sense at the mercy of the people who are building the devices almost no matter what we do, because, you know, we shouldn't insert backdoors into TLS for our own good. They will hurt us more than they will help us. So just
Thank you for your comment. I'm somewhat aware of the debates that have gone on in the TLS working group. My main goal was to call attention to the severity of the problem. I'm not claiming that I know what the right solution is, but I think the current situation is perhaps not optimal.
Thanks.
Over here.
Max Pala, Cable Labs. Thanks for the talks. I would like to ask you a question following the gentleman from German Telecom about ownership of the data. This is a very big difference in the US and Europe, for example, where ownership of the data is always about me when I'm in Europe, and once it's collected in the US is property of who collected the data. And that's, I think, is the biggest issue when privacy. Instead of giving out your data, you can borrow my data, but I can always ask you to remove my data from your system whenever I want to. You know, I don't want to have business relationship with you, etc. And if you can elaborate on that, if you think that this might be a tool that enhance privacy from a legal standpoint of view, in the sense that give me as a user a possible recourse of action in case you're failing to protect my privacy. And the second point is about the measurement. You said that, you know, this type of privacy issue came out because of measurements. Maybe it's time to talk about having measurements as part of the legal framework so that it's not left to academic to expose this, but with bodies that actually have authority to follow up on that.
Data ownership is a really complicated question. There's been a fair amount of legal writing lately, legal academic writing, on why trying to treat data as property can have bad side effects. One of the interesting things from US law is that a lot of these transactions, there are two different parties that have ownership. So I mentioned about my mechanics uploading or selling my odometer readings. Well, yes, my mechanic is recording the odometer reading to go let me know when I should change my oil again. And that becomes a business record of the mechanic. And that's the property, the data belong to the mechanic, and therefore the mechanic can sell it as well as me. And my privacy problem is that it gets aggregated and attributed to me as well. So there are very complicated questions with trying to treat this as property, even apart from the international issues of different philosophies. There's a lot of data that businesses very legitimately have to collect, and medical personnel utterly rely on it. They need this to keep you healthy. They have to have this data, and then who owns it? So it's not an easy question, so, which is why I like the notion of use control instead.
I just want to say a couple sentences about the measurement issue that you raised. I agree 200% that measurement should be a standard part of the regulatory process. And just to tell you how much I agree with that, at Princeton, I'm part of the Center for Information Technology Policy. And it was started 15 years ago with precisely the notion that there need to be more technologists in government, exactly because we can do more of the sort of things you're calling for, because today the main limitation is just the technical expertise that exists in regulatory agencies.
If you're a technical person, get involved with your own government. Make sure the lawyers, judges, legislators, regulators, and so on understand the technology. I've done this twice. I highly recommend, 3 times. I highly recommend it.
And now the last word, Phil, you have negative 4 minutes. So
Okay.
please be extremely brief. I'm sorry, back mic, we cut the mic lines a while ago.
Okay, so name withheld, actually. So Steve said we had the wrong trust model. You know, we got to think beyond the CIA, et cetera, attacking. I think it goes beyond that. These third-party databases, they are a national security threat. And we saw them weaponized in 2016. And it isn't just personal data. I know of an insurance company that is operated by an individual who is widely believed to be operating on behalf of an intelligence agency, a hostile one. This insurance agency specializes in commercial vehicles. If you think about what such an insurance agency would be doing, it is collecting data on all the trucks that are moving in that country. And they managed to get 70% of the market in a remarkably short time because businesses are very price sensitive. So when we're thinking about this thing, it is no longer just us as individuals having concern about our personal privacy. It is also a matter of national security and patriotism.
2 major data breaches of multinational U.S. firms are frequently thought to have been perpetrated by a foreign intelligence agency. The Equifax and the Marriott breach have been attributed to foreign intelligence agencies. In fact, someone from Equifax said, I saw this just yesterday, they've seen zero evidence that any of the stolen data has been used commercially for identity theft or anything else, which kind of goes along pretty well with the notion that it was an intelligence agency that took it. So yeah, this is very plausible.
So thank you very much. We now have a 4-minute break, I think, before the administrative plenary. I'd like to thank again very much both Steve and Arvind. This was an excellent evening. I learned a lot. I especially appreciate the challenges to the IETF from both of you, and we hope to live up to them. So thank you very much. We'll see you in 180 seconds.